let's look at probability and let's start with the notation. So our way of saying the probability of event A is this. That just says the probability that event A occurs. A few standard facts that we should know. The probability of A must be between 0 and 1. 0 meaning that the event A is impossible, 1 meaning that the event A is certain. Most events will be somewhere in between 0 and 1. So we also have the event A happens, or we call it A supplement, the probability that A does not happen, just represented with a little dash there. The probability that A does not happen is 1 minus the probability of A. Thinking that through, that arrives from the probability of A happening added to the probability of A not happening must be 1. All that tells us is an event happens or it doesn't. One of those two things must occur. Okay, so what if we've got two separate events? We've got event A and event B. Usually, as with most maths, we want a diagram. Venn diagrams are a great way to start and they help us understand the notation as well. So we've got event A and event B. This green section in the middle here, we would denote as A intersection B. So it's A and B. That is that intersection where both events happen. So that is A and B. Okay? We also have this whole region here. So we could have this region. We would denote this A union B. Sorry, my red pen's not working very well. A union B. We would call that A or B usually. So that is the probability, or not probability, that is the event that it is in A or B. Notice that the event OR has also shaded this green region, which we would call AND. So OR in this case does mean AND OR B. Okay. We can then have combinations of these. So for example, if we had our event A and our event B, it's possible that we may want to look at the probability of A or not B. So how would we shade this area? Because it says OR, it only needs to meet one of these two criteria for us to meet it. So let's look at this first one, A. So we're going to shade everywhere which is in A. Okay? Then we have OR B, or not B, sorry. So we're now going to shade everywhere which is not in B. So you'll notice that this region here, this bit, has been double shaded. But just like before, when we say OR, we do mean AND OR. It doesn't matter if it's been shaded twice. So if we wanted to know the probability of these two events, what we would do is we would add together all of these regions here. So let's look at a numerical example in this case. So if we just clear that area a little bit. Let's say we had numbers 0.4, 0.05, 0.25. Now, we don't have a free choice for this outside area because we know the probability of something must be 1. So if we look at this, adding these together, we've got 0.3 0.7. So out here must be 0.3. So the probability of A or not B, we want anything which is in A, meets the first criteria, and not in B, which is this criteria here. So you'll notice that we've added together the three areas that we shaded previously. So we get a probability of 0.75. Alternatively, we could have done 1 minus the one area that we didn't shade. Okay, that's how we can use Venn diagrams to help us understand the notation of probability.